Hey everybody, it's Mr. Carr again. Today we're going to be looking at 7-2 day 1, solving exponential equations. All right, so we talked about graphing before. Today we're going to talk about solving them, doing our algebra skills with this. So what's going to help is to understand some of these basic exponents with all the different bases here. So for example, base 2, 2 to the 5th is 32, 2 to the 4th is 16, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0, 2 to the -1, 2 to the -2. These are very helpful for what we're going to do today. Same thing with base 3. So we have 3 to the 4th, 3 to the 3rd, 3 squared, 3 to the 1st, 3 to the 0, 3 to the -1, 3 to the -2. Here's 4 cubed, 4 squared, 4 to the 1st, 4 to the 0, 4 to the -1, 4 to the -2. And here's 5 to the 3rd, 5 squared, 5 to the 1st, 5 to the 0, 5 to the -1, 5 to the -2. Okay, so these are some basic versions that are going to be very helpful for what we're going to do here. So look at our first problem here. Okay, there we go. The goal here is to rewrite so the left and right sides have the same base. Set the exponents equal to each other and then solve from there. So when we look at this, you notice how we have 2 and 4. Well, I can rewrite 4 with base 2. 4 is the same as 2 squared. Okay, that's freezing up a little bit, but so if I rewrite this, it's going to be 2 to the 5x is equal to, about 1 second. Sorry about this. Let me pause real quick. There we go. Sorry, just had to refresh that a little bit. So because 4 is the same as 2 squared, I'm going to rewrite this one with that base 2. So 4 is 2 squared, and that's raised to the 2x minus 1 power. Well, remember, when we raise a power to a power, we multiply those. So I'm actually going to take the 2 and distribute it to all of those. So 2 to the 5x is equal to 2 to the 4x minus 2. With the bases being the same, we know that the exponents also have to match up. So that's why I'm just going to do step 2 now, which is just say 5x equals 4x minus 2. Okay, now it's just a matter of solving that. So if I subtract 4x over, x equals -2, and that's it. Okay, it's a good idea to check over that and make sure it does work, but we're going to move on to some other problems on this one. So solving this equation, same thing, 4 and 64. I can either write both of them in the same base of 2, because they both have perfect squares like that, or 64, where 4 to the 3rd power is 64. So I can do it that way. So 4 to the x is the same as 4 to the 3rd to the 3rd. Okay, so that means I'm going to multiply these two together. So 4 to the x is equal to 4 to the 9th. Well, that means that x just has to equal 9. So there's multiple ways to do it, but I'm looking for the shortest way in this case. All right, so it looks a little bit harder. And that's because we have to deal with negative exponents. Okay, so because I don't have a direct connection between the 27 and the 81, we're going to do both of them as base 3. So 1 over 27 is the same as 3 to the -3. 81 is the same as 3 to the 4th. So I'm going to rewrite this as 3 to the -3 raised to the 2x minus 2 power. 81 will be 3 to the 4th raised to the x plus 4 power. Just like before, we are going to multiply these exponents together. So I'm going to distribute here, and I'm going to multiply these together by distributing the 4. So 3 raised to the -6x plus 6 equals 3 raised to the 4x plus 16. Bases are the same. They're both base 3, so that means -6x plus 6 equals 4x plus 16. And now we just solve this out. So I can subtract 4x over and subtract 6 over. So that's a -10x. That's gone, and that's equal to a +10. So I divide by -10, and I get x equals -1. Okay, and that's our goal. So we can see this one's going to be one you can try on your own. So if you want to pause it real quick, give it a shot. But outside of that, that's another one you can try, or no, that's the same page actually. So we're going to move on from that. Let's talk about writing an exponential function for this. In 2000, the population of Phoenix was 1,321,045. By 2007, it was estimated at 1,512,986. Write an exponential function that could be used to model the population of Phoenix. Write x in terms of the number of years since 2000. So we're going to use your function to predict what the population will be in Phoenix in 2013. So I just got to pull up my calculator real quick because I'm going to need that here. So thinking back to what we did before, this is going to be an initial amount. So we're going to use this idea. We got exponential growth here. So the amount is going to be based on, we'll call it a sub 0 for initial amount. Now let's just do lowercase a. Yeah, let's just do it this way. What we did yesterday was y equals a times 1 plus r raised to the t power. So here's what we have. We do not know for sure. We know that it's growing after 7 years. And we know what the amount is here and the amount is here. Okay? So that means I can say that 1,512,986 is equal to the A value, the initial amount, which is 1,321,045. And that's going to be multiplied by 1 plus r for now, raised to the 7th power. Okay? So the goal here is we want to solve for r. We want to try to figure out what that r value is so that we can use that to help us predict the 2013. So just 1 second here. Change it up a little bit. I'm actually going to, instead of 1 plus r, we're just going to call it the b value here. This is going to be the growth factor, but just recognize that it's still that 1 plus r idea. So we're going to divide both sides by 1,321,045. 321,045. Okay. We do that, and we're going to get about 1.145. And that is equal to b to the 7th power. Here, we're going to undo the 7th power by taking the 7th root of both sides. So once I do that, I get 1.0196. That's going to be my b value. So that means the first part of this, I want to write in terms of x and y for years and everything. Y is equal to the initial amount, 1,321,045, multiplied by the b value, which is 1.0196, raised to the x power. Okay, so what that means from there is I'm going to use that to determine in the year 2013, what's the population? Well, if we're going off of years since 2000, that means my x value here is 13. So now I just use this equation, do 1,321,045 multiplied by 1.0196 raised to the 13th power. Okay, so this is a calculator work. Raise that to 13th power, multiply by this, and the population will come out to about 1,700,221 people. Okay, so again, that's as a quick reminder, we're going to use this idea, the initial amount, the amount after 7 years. We can use that to solve for B and then use that for our model of the scenario. After that, we can use that to make our predictions. Okay, so this is another one you can try on your own for the town of Tisdale. But otherwise, that is it for today. All right, we'll continue more with 7.2 next time. Take care, everybody.